So these are molecules with the same formula but different shape. So like propanol and isopropanol from yesterday, same formula, different shape. So we're going to draw a bunch of different versions of pentanol today. And the first one, so what we do is, let's just write this in here. We use numbers to denote the position groups. That means oxygen today. And double and triple bonds. Alright, so here's how this works. We're going to start off with, I'm going to write it. Alright, we're going to start off with one pentanol. Okay, so say you're going to write one pentanol. And the one tells us that the oxygen is going to go on the first carbon. And you say, well, which one's the first? Well, let's see. So we're going to call this one the 1 carbon. And if this is the 1, then this has to be 2, 3, 4, 5. You have to stay with the same system if you have more than one thing attached. So we're going to put our oxygen on the 1 carbon. I'm going to put it on the bottom just because I don't want a lot of space up there. Again, if you actually build the thing in 3D, it doesn't matter if you put a top, bottom, or side. They're actually the same, just spinning molecule. And then we're just going to fill this up with nitrogen. Alright, next we're going to draw here 2 pentanol. So again, we're going to have 5 carbons. We're just going to put the oxygen on the 2nd carbon. Right. So in this drawing, this is the 1 carbon, this is the 2 carbon, this is the 3 carbon, 4 carbon, and 5 carbon. So we just number the carbons. So 2 pentanol. We're going to have C, 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 and we'll call this, again, 1, 2, 3, start from the outside and count. 3, 4, 5. So this one's going to be number 2, it gets the oxygen. And the rest of the drawing is the same. Now, if I draw these for you and then I ask you to name them, all right, then you start at whichever side the thing is closer to, right? So let me show you. I'm going to draw one, and then we're just going to name it. So here's one. Okay, so there's my 5 carbons, and I'm going to put an oxygen here, and then finish drawing this. So the rule for naming these things is you always start numbering the carbons from the side closer to where the functional group is. So what is this going to be called? You would think it should be 4, right? Because you think we should do 1, 2, but it's actually going to be 2, because since the oxygen is closer to this side, this is going to be our 1 carbon. So we're going to go backwards, 1, 2, 3, 4, 5.
So, does it ever get to 4 and 5?
Does it ever get to 4 and 5? That's a great question. Now, why wouldn't it get to 4? Why shouldn't we have a 4 there? Now, here's the answer, right? This is 2-pentanol. This is the one we thought should be called 4-pentanol, but it's really going to be 2-pentanol either. Also, are these the same or are they different?
They're different. Same.
They're the same, actually. This is the first 2-pentanol up here, right? I got 1, 2, here's my second carbon, there's my oxygen. Now let's look at this one down here. Isn't this the same? Isn't this also this one? 1, 2. I just spun it around. So I don't have to pull any pieces off. These two are still the same thing. So if I draw the oxygen on the second carbon on this side, or the second carbon on this side, it's really the same molecule. I'm just turning it around. Now 1-pentanol is different, right? 1-pentanol, my oxygen's on the end. So 1-pentanol or 5-pentanol would be the same thing. 5 doesn't exist because of the numbering system. But 1 and 5 would be the same thing. 2 and 4 would be the same thing. So this is 1, this is 2, and then the only other choice is 3. You don't have a 4 or 5 because that would be redundant. So, does that make sense?
Well, what if we have more like 5?
If there's, so what do you mean, like 7 or 8?
Yeah, we got 7 or 8.
If it had 7, it'd be 2-heptanol or 1-heptanol. We would change the name.
But would it ever go to like 5?
Yeah, so if you had something with 11 carbons, it could go to 5, right, or 10 carbons. If you had decanol, you could have 5 decanol, 1, 2, 3, 4, 5. But you can never go more than halfway the number of how many there are, because you know if you go over here, it's just the same molecule. So yeah, however many carbons there are, the number should never be more than half that. Well, I guess if it's this one, 3-pentanol, it would be just over half, so the middle carbon. But you'll never go past the middle carbon. Should I do more like this, or are we good with this?
So I think that's the third one. It doesn't matter, so it'll be 2 or 4.
No, the third one will be 3, right? So, yeah, let's do that one. So yeah, 3-pentanol would be different. Yeah, so this one would be called 3-pentanol because there's no way I could take this one and make it look like 1-pentanol. Any way I turn it, it's still the third carbon in from either side. So this is never going to look like a 1-pentanol or a 2-pentanol. Can I pass these around? Or? No, okay, so there's 1, 2, and 3-pentanol. There's not a 4. 4 is 2. There's not a 5. 5 is just 1. All right, let's. Can I erase her?
Yep.
This is 3-pentanol. Oh, yeah, I should have wrote that down. So this one's 3-pentanol. So I guess I'm going to erase this first one, 1-pentanol. So the rule, the formula for all 3 of these is going to be C5H12O. Yeah, so remember with isomers, they'll all have the same formula, they'll just have different shapes. So the particles will be in different places, right? Just like you could take a bunch of these little toys and rearrange them to keep the same number of black balls and the same number of white balls and the same number of red balls. So you could have a bunch of different shapes out of that. So that's how isomers work. All right, so let's write down the rule here for numbering these things. So start on the side closest to the functional group. Remember, this is called a hydroxyl group, right? And number carbons. One, two, whatever. How many there are. indicate position or function.
Bless you.
Or a double bond or triple bond, same thing. We number where they are the same way. And when we're doing double and triple bonds, you use the number of the first, the lower of the two numbers. Like if there's a double bond between carbons 2 and 3, you would say 2, pentene, or whatever it is. All right, let's go ahead and do one of those. Let's say we had, that. Okay. We'll fill in the rest of it. 2 hydrogens on this one, 1 hydrogen on this one. So if anybody missed any days recently, remember every carbon gets 4 bonds, right? So this one already had 2, so we put 2 hydrogens. This one already had 3, so we put 1, and so on. Every carbon should have 4 little lines attached to it.
Is it possible for 2 carbons that have 4 connected?
Quadruple bonds? I've never seen it. So I don't think so. I can't say for sure it's impossible. All right, so what are we going to name this one? Oops. You guys write this already? Okay. So what are we going to name this thing? 7. All right, it's got 7. So what prefix does it start with? Hept. And then it's got a double bond, so what's the ending? ENE, right? It's an alkene, so it's got a double bond, so it's going to be heptene. So we got to put a number now to indicate where the double bond is. What's the number going to be? Well, we start on this side, right? Because the double bond's on this side. 1, 2, 3, 4, 5, 6, 7. We take the lower of the 2 because it connects to 1 and 2, so we're going to go with the 1 carbon. So it's 1 heptene. And again, we could have 2 heptene or 3 heptene. If we had the double bond on this side, it would just be the same thing. Like if it was here, it would also be 1 heptene because we'd start on this side. So you wouldn't see 7 heptene or 6 heptene. Let's do one more. Let's do, oh no, that would be kind of redundant. Yes?
Why was it principle
Well, this is heptene, not heptanol. Heptanol would get an O, heptene gets a double bond. All right, let's do this one. Oh, no, wait, I keep doing, no, let's not do that. Let's do this one. So first let's draw, how many hydrogens on this carbon? 2, right? How many on this carbon? 1. It's already got 3, right?
Oh.
So it gets 1. How many on this carbon? 2. How many on the last one? 3. Right. That's kind of sloppy. Okay, so what are we going to call this thing? Or where are we going to start numbering from? The right side, right? So it's going to be your 1, 2, 3, 4. So what's that called? Butene. And what number am I going to put? Yeah, so it's going to be 1 butene. So you just look at the 2 carbons that the double bond is touching, pick the lower one, right? How about yeah, let's do that. What's that gonna be called? Two propanol. Two because the oxygen is on the 2 carbon. This is right in the middle, so either side we start from. It could be 1, 2, 3, or 1, 2, 3. It's still going to be the 2 carbon, whichever way we go. So anytime you have an odd number and it's on the middle carbon, it doesn't matter which direction you start from. So 2, there's 3 of them, so it's pro, right? 3 carbons, and it's an alcohol because there's an oxygen here, so it's propanol. All right, one more. How about we'll get 1, go 1, 2, 3. All right. One propine, right? It's got a triple bond, so it's going to have YNE as the ending. It has 3 carbons, so it gets pro. 1, 2, 3. This will be 1 propine. So the objective here today is that you're able to draw 1 propine, 1 propanol, 1 propene. We can't have 1 propane, right? Because there's nothing to indicate the position of. Should I do any more? All right, get this. Okay. Alrighty. Mohammed, should do me a favor. Make sure you get 2 pages. Just like this. Can you yourself up again?